we will discuss about vapor pressure. So first of all, we want to define vapor pressure. So along with vapor pressure, inshallah we will discuss about some important numericals of vapor pressure. So first of all, what is vapor pressure? So the pressure exerted by the vapors, when the rate of evaporation become equal to rate of condensation. Clear? So you know, when we vaporize anything in closed container, so after some time the vapors start condensation. Condensation means the vapors become liquid after some time. So we start again. So for example, this is a container. Clear? And this is also another container. Clear? So if there is some amount of water or liquid. Clear? So when we give or heat this liquid, then the vapor start. But you should know, evaporation is a spontaneous process, is inactive process. Clear? So this is an open container while this is a closed container. Clear? So for open container, when we heat the liquid, so for such situation we only study boiling point, because you know what is boiling point. Boiling point is the point of temperature. Boiling point is actually the point of temperature where a liquid start boiling. Means a boiling point is actually the point of temperature where the vapor pressure become equal to atmospheric pressure. Clear? So this is a type of liquid. When we heat this liquid, then its evaporation speed up, means its vaporization starts. So after some time, you know, from to downward there is a atmospheric pressure. That is atmospheric pressure. From lowerward, that is vapor pressure. So when the vapor pressure become equal to atmospheric pressure, this point is known as boiling point. Again, what is boiling point? Boiling point, when the vapor pressure become equal to atmospheric pressure, then this point of temperature is known as boiling point. Just like for water, 1 atmospheric pressure. For example, if this is a water, then if the pressure is 1 atm, then boiling point will be 100 Celsius. Clear? So now we are going to discuss actually vapor pressure. So it means we don't discuss vapor pressure for open container. Now we discuss vapor pressure for closed container. For example, this is a closed container. Clear? So this is a closed container. I want to magnify it. Clear? So when we heat up this container and this is actually closed, then evaporation or vaporization starts. Vaporization or evaporation means gasification starts, means these liquids converted into gas, or the conversion of liquid into gas starts. So this is a lead from which the gas molecule cannot escape. So with the passage of time, the gas molecule increases. If you concentrate here, when we heat this container, the gas molecule escape or leave from this container. But if you concentrate here the liquid is converted into gas, but gas cannot leave this container. Clear? And so with the passage of time, the number of gas molecule increases in this space. So if gas molecule increases, the chance of collision is also increases. If the chance of collision increases, the reaction or the probability of the reaction increases. So what happened? A physical reaction takes place, that is condensation. So after some time, the rate of evaporation become equal to rate of condensation. Rate of evaporation means the speed at which the vapors are forming become equal to the speed with which the vapors become liquid. So at that point, the rate of evaporation become equal to rate of condensation. So now what is vapor pressure actually? So vapor pressure is actually the pressure exerted by the vapors when the rate of evaporation become equal to rate of condensation. Easy? So go ahead. So now I want to discuss about a partial pressure or pure vapor pressure. So now consider this is a container having a liquid A. So when we heat it, then the formation of vapor starts. Clear? So after some time, the rate of evaporation become equal to the rate of evaporation become equal to rate of condensation. So at this point, the temperature, the pressure exerted by these vapor, when the rate of evaporation become equal to rate of condensation, this is called vapor pressure. So now we discuss vapor pressure of a pure substance. For example, this is a H2O. This is an H2O, while this is a, for example, alcohol. Suppose for example, C2H5OH. Clear? Okay. So now when we heat it, its vapors formed which exert pressure on all sides of the container. So now we imagine it, the pressure exerted by this substance, which is in a form of liquid substance. This exert pressure. So the pressure exerted by a pure substance is denoted by PA, partial pressure of a pure substance. Partial pressure of a pure substance. While this is also a pure substance. Clear? C2H5OH. This is also a pure substance. When we heat it, its vapors formed and vapors exert a pressure. So in such a situation, in a pure form, its vapor pressure is also denoted by, for example, PB. For a pure form, we add another trick, another identification point, that is naught. So on the base of this naught, we can differentiate the pressure of the liquid in a pure form while in a mixture form. So you should know, we represent the vapor pressure of this liquid and this liquid in a pure form by P naught A or P naught B, or P naught W means water, P naught alcohol. Clear? In a pure form. This means in a pure form, the pressure exerted by this substance in this substance are represented by P naught W and P naught A or P naught A or P naught B. Clear? So when we mix it, So the mixture of these two substances formed, number one is alcohol, number second is water. Clear? So now here they will also exert a pressure, to which we will represent as P A or P B. Pa for example for alcohol and Pb, suppose Pa for example for water. Now we remove these two. Pa for water in a mixture form, Pa not for water in a pure form. The pressure exerted by the vapors of water in a pure form, the pressure exerted by the water vapors in a liquid form, in a mixture form. Clear? Sorry. This denote that the pressure exerted by the vapors of liquid in a mixture form, while this is a pressure exerted by the vapors in a pure form. P0B shows the pressure exerted by the vapors of this liquid in a pure form, while P0B shows the pressure exerted by the vapors of alcohol in a mixture form. So now we want to apply Raoult's law. How we will calculate the vapor pressure? How we will calculate the vapor pressure, but partial vapor pressure of any substance in a liquid form or in a mixture form. Clear? So we can find the partial vapor pressure of any liquid in a pure form, but when we want to calculate the partial vapor pressure of any substance in a liquid form, then we will apply Raoult's law as well as Dalton's law. So first of all, you should remember that according to Dalton's law said that the vapor pressure exerted by the mixture of gases is equal to the total vapor pressure in a solution form, in a mixture form of different type of gas, will be equal to sum of the partial vapor pressure of each gas. No? Okay. So here we apply both law. Number one is Raoult's law. Is Raoult's law. Clear? So according to Raoult's law, the partial vapor pressure of any substance in a solution form is directly related to its mole fraction. Again, the partial vapor pressure of any substance in a solution form is directly related to mole fraction of this substance. Can we write it as? So suppose this equation can be written as Pa is equal to Kxa, and this one can be written as Pb is equal to Kxb. So now this is a solution. If the mole fraction, do you know about mole fraction? If you don't know about mole fraction, so type mole fraction and also type learning group RF, you can find something or everything about mole fraction, which video is already present at this channel. Clear? So now this is a partial vapor pressure of A. This is a partial vapor pressure of A in a solution form, while this is a partial vapor pressure of B in a solution form. Clear? So now if in this situation, if I remove alcohol, so this container and this container clear? So this container become equal to this container. It means this pressure will become equal to this pressure. So now I can write it as PA is equal to P naught A XA. Clear? So again, if I remove water from this container, it means this container become equal to this container, which means this pressure become equal to this pressure. So now I can write this equation as, clear? So now this is the pressure of the liquid in a pure form, while this is a mole fraction of this species in a solution, and this is a partial vapor pressure of a substance in a mixture. This is a partial vapor pressure of a substance in a mixture. This is a partial vapor pressure of a substance in a pure form. This is a mole fraction of a mixture of a substance, that solution. Clear? So again, now we want to apply Dalton's law. So what Dalton's law said? According to Dalton's law, if this is a solution of different type of gases, so the total pressure in this solution exerted by the gases will be equal to partial pressure of A plus partial pressure of B plus partial pressure of C. So now we apply Dalton's law here. So it means the total pressure of the mixture will be equal to PA plus PB, or total pressure applying by the mixture of a gas will be equal to P naught A plus P naught B. Clear? So by using this formula, we can calculate the sum of the pressure of the gas in a solution form. Clear? So now I want to solve a numerical question about this. So you should also remember that here we take a volatile substance in volatile. Here we mixing volatile vapor pressure for volatile and volatile. Clear? The first substance is also volatile, the second substance is also volatile. So there is also vapor pressure. Inshallah we will discuss where one substance will be volatile and the other will be non-volatile. Clear? The solvent will be volatile and the solute will be non-volatile. Non-volatile means solid. Clear? Here both are volatile, but we will discuss lowering of vapor pressure, depression of depression of melting point. Clear? Or increasing of boiling point. So inshallah we will discuss with the passage of time, but in this case we study liquid in liquid, volatile in volatile mixture. Clear? So now you can write it and learn. So take a screenshot and I take a numerical question for you. So the one term to which I have repeated again and again is that sometimes we use some word in the concentration terms, that is molar, normal. Clear? Molar means 1 mole. Molar solution means 1 mole in liter or 1 liter of dm cube of solution. 1 mole in dm cube of solution. Molar. Molal, 1 mole in kilogram of solvent. Clear? And also we have discussed normal. Clear? So gram equivalent, number of gram equivalent divided by volume in dm cube. So clear? So now we are adding such further, that is semi-molal or semi. Now we study about semi-normal or semi-molal. Semi means 1/2. Deci means 1 by 10. Centi means 1 by what? 1 by 100. So now I want to share some numerical problems of vapor pressure. For example, we have a mixture. We have a mixture of two substances, that is a mixture. It is a mixture of water, H2O, and also C2H5OH, clear, where the mass of H2O is 54 gram and mass of alcohol or ethanol is 192 gram. 192 gram, clear. So if partial vapor pressure, if the partial vapor pressure for a in a pure form for water is partial vapor pressure in a pure form by knot of water is equal to 600 mm of Hg, and a pure partial vapor pressure for ethanol is, for example, 400 mm of Hg. Find the partial vapor pressure of water and also partial vapor pressure of alcohol, Al, of alcohol, clear. This is a data. This is a mixture of H2O and ethanol. Partial vapor pressure of water is that, while partial vapor pressure of ethanol is that. Find partial vapor pressure of water and partial vapor pressure of alcohol. So you know that the pressure exerted by something in a solution form is equal to P naught A into mole fraction of this substance, clear. So now we write this equation for what? For water. So now partial vapor pressure of water is equal to, in a pure form, vapor pressure multiplied by mole fraction of water, clear. So again, now we will calculate that. So now PW, partial vapor pressure in a solution form, is equal to P naught W. P naught W is 600 mm of Hg, 600 mm of Hg multiplied by mole fraction of water, clear, mole fraction of water. So you know mole fraction of anything, for example of A, is equal to moles of A divided by moles of solution, total moles of solution. So now we should convert, or we should find the mole fraction of water. So here you can find first mole fraction of water and then put its values. So now we want to calculate mole fraction of water, which is equal to moles of water divided by moles of alcohol plus moles of water. This is a mechanism to calculate mole fraction. So now what number or what amount of number of water is present here, clear. So number of moles of water is equal to mass of water divided by molar mass of water, which is equal to mass of water is 54 grams divided by molar mass of water is 18 grams. Clear? 18. So 18.1 and 18.3. Clear? So number of moles of water, so mole fraction of water is equal to, number of moles of water is 3 divided by 3 plus, so now we will find number of moles of alcohol, which is equal to mass of alcohol divided by molar mass of alcohol, which is equal to mass of alcohol is 400 नहीं, mass of alcohol is 192 grams, 192 grams, and molar mass for 24 plus 5 plus 16 plus 1, so 20 plus 24 plus 1 25 plus 5 30 40 46 grams. So divide by what 3 3 or for example 46 multiplied by 4 4 16 180, and if we divide by 5 5 5 multiplied by 6 30, 5 multiplied by 4 20 23. Clear? 192. Is it correct? 24 plus 5 plus 16 plus 1, so 24 plus 1 25 30 40 46. Clear? So now we will find here 192 divided by 46, so 46 and by 4 4 4 multiply 6 is equal to 24, 2 carry 4 multiply 4 18. Clear? 4 multiply 4 24, 4 multiply 6 24, 4 multiply 4 16 17 18. So answer is 12 minus 4 7 6. Clear? 6 7 8 1 carry 0 and 0. So which is approximately number of moles of alcohol is approximately equal to what? 4. So number of moles of alcohol is approximately 4. Clear? 4 or 4 4. Clear? Okay. So now we were finding the mole fraction of water. So this is the moles of H2O, this is the moles of H2O, while now we will write the moles of alcohol, which is 4. Can you see it? Okay. So go ahead and solve it. So now mole fraction of water is equal to 3 divided by 4 5 6 7, which is equal to 3 divided by 7.042202 and 1 approximately 0.42. So mole fraction of water is approximately equal to 0.42. Clear? So now we will find the partial vapor pressure. So mole fraction of water is equal to 0.42. Clear? Okay. So you should solve the question completely. Clear? Okay. So now we can write it as um, 0 0 6 12 and 6 4 25 to approximately is equal to partial vapor pressure in a solution form is approximately equal to mm of Hg. Clear? I am using approximate, the word approximate, not equal to. Clear? Because I have not fully solved the calculation just like here. You should solve the question or solve the numerical problems till the end. Clear? So this is a partial vapor pressure of water. So now we want to calculate the partial vapor pressure of what? Of alcohol. So partial vapor pressure of alcohol is equal to partial vapor pressure in a pure form of alcohol multiplied by mole fraction of alcohol. So now partial vapor pressure of alcohol in a solution form is equal to partial vapor pressure is equal to 400 mm of Hg multiplied by mole fraction of what? Of alcohol. So mole fraction of alcohol mean mole of alcohol divided by moles of alcohol divided by moles of alcohol plus moles of water. So can we write it as 400 mm of Hg multiplied by 4 divided by 7.0 अब 35 5 remainder 0 7, so approximately 0.57. Clear? So go ahead. Can we write it as 0 0 4 7 4 multiplied 5 20 plus 2 22 point here mm of Hg. So this is a partial vapor pressure of alcohol in a mixture form. Clear? So next question is that what is the total vapor pressure? What is the total vapor pressure of the solution? What is the total vapor pressure? So in order to find the total vapor pressure of the solution, which is equal to total vapor pressure of solution is equal to vapor pressure of water plus vapor pressure of vapor pressure of alcohol. So the vapor pressure of water put here plus vapor pressure of this is 228. Clear? So by this way you can find the total pressure. Add the vapor pressure of water plus add the vapor pressure of alcohol. So by this way you can find the total pressure of the solution. So it's all about the vapor pressure of volatile and volatile substance. When we mix two volatile substance, then what will be its vapor pressure in a solution form? So now we applied Raoult's law as well as Dalton's law and also derive two or one, basically three equations. That two were related to Dalton's law. The second one, the two was related to Raoult's law. The second one related to Dalton's law. And by this mechanism, you can find the partial vapor pressure of any matter in a solution form, and as well as you can find the vapor pressure of any substance in a pure form. So I hope that you have learned some more of this video. So if you want to watch such type of beneficial lectures, you should subscribe our channel. If you subscribe the channel, you can find more some such contents of this channel. So okay, good luck.